Good morning, students. Hi, this is Avi sir, and today I'm going to upload my second tutorial videos on Python Pandas. Like last day, I have discussed about data series, and today I'm going to discuss about data frames. Now, as all of you remember that data series is nothing but a single dimensional data structure. On the other hand, a data frame is a two-dimensional data structure. But in a data frame, we can able to store different types of data simultaneously. This is the difference of data frame with the NumPy array. In NumPy array, we can only able to store the homogeneous type of data, but in case of data frame, we can also store heterogeneous or different types of data. And one more thing, all the data frames are of mutable data type. That means we can able to change the value also. Now we are coming to the characteristics of a data frame. Number one, it has two axes. The row axis is also called the axis 0 and the column axis is also called the axis 1. This is also same like NumPy array. Now number two, it is similar to a spreadsheet application like Microsoft Excel. Just wait, let me open a Microsoft Excel sheet for you. Yes, this is the Microsoft Excel. So you can consider a data frame is this type of data structure. It is just like a table with some rows. The horizontal lines are the rows and this 1, 2, 3 are the row labels or row names I can say, or you can say it a row index. And this A, B, C, these vertical lines are called columns and this A, B, C are the column labels or column names. So basically data frame is nothing but a this spreadsheet type of data structure. Now point number 3, index can be customized. That means you can, if you want, you can able to change this name of the indexes or the labels. The default index will be from 0 to n. Then number 4, the data across the columns can be of different data types. As I told you, since it can store a heterogeneous data type, so that means from one column to another column we can able to change the type. Then the values are mutable, we can change the values. And the last point is size of the data frame is also mutable. This is another difference with NumPy array. So basically in case of NumPy array, the size is fixed. Suppose if the size of the NumPy array is 5, we cannot able to store 6th element within this. But in data frame, it's possible. We can able to modify the size. Next, the creation of a data frame. A data frame can be created with the following constructs. Number one, we can convert a list or maybe a data series or dictionary or NumPy array or another data frame, and the last one is a CSV file. So we can convert all these data structures to a data frame. Now the function is called data frame. This function belongs to the Pandas library, and you also need to remember that within the function the letter D and the letter F will be in capital letters, otherwise you will encounter an error message. So this function is used to create or convert a data structure to a data frame. Now the syntax, how to use this function. Firstly, you need to import the pandas library. So import pandas as PD. Then you need to create a variable. Actually this X is the variable. Basically this is a data frame variable. So X is equal to pd.dataFrame. That means I'm calling this function and we need to pass some arguments within this function. Now what are these arguments? First argument is called data. Data means it can be a list or a dictionary or a data series, whatever you want to convert to a data frame. The second argument is index. Index means nothing but the row labels. Now if you don't mention anything, then the by default Indexing will be starting from 0, 1, 2 like this. It will go so on. If you want, you can able to change it. The next attribute is column. Now the same thing, columns are also known as the column labels. By default, it will also start with the value 0, 1, 2. If no index you have mentioned, then by default it will take with the value 0, 1, 2. Now if you want, you can also change it. The next argument is called dtype. Dtype defines the data type of each column. As I told you earlier, maybe you remember that data type can be changed across the columns but not across the rows. Now the last one is copy. It is used to copy the data from any other structure. Basically, we don't need to use this thing, and if you don't write anything, the default value this argument will take is false. Now we'll go and demonstrate some programs. Just wait, let me open my spider IDE. Okay, now look at the program. The first one. Now take the program. Import pandas as PD. Then x is equal to pd.dataframe. Then I have passed a list within the dataframe function. So this list will contain three different elements. Then print x. Now let me run the program for you. See the output. One data frame is created. This left hand side, the 0, 1 and 2. These are the row labels or the row names. As I told you, by default the row labels are 0, 1, 2 like this, since I have not mentioned anything. And the 0 is the column label or the column name. Here also I have not mentioned anything in column attribute. That's why the default value will be taken as 0, 1, 2 like this. I believe all of you can able to understand this thing. Now I'll go to the next one. Just let me copy this thing. Now the program is same like the previous one. Only the difference is here, instead of a list, I have passed a tuple. Just let me run this thing for you. You can see the output is same. So that means not only list, we can also able to convert a tuple to a data frame. Now the third program. See, now in the third program, I have converted a dictionary to a data frame. Basically, this dictionary contains three different elements. In all the keys, I have stored the letters like A, B, C. These are the keys, and their corresponding values are 1, 2, and 9. These are the corresponding values. Now, I have converted this dictionary to a data series. Like last day, I told you the purpose of series function is to convert a dictionary to a data series. And then I have converted this data series to a data frame. So pd.dataframe, then y. Now, if you print x, you will get a data frame. Now, see the change here. If you are going to use a dictionary, then all the keys, as all of you know, that this will become the labels for a series, and the same thing will be happen in case of data frame also. The row labels will become A, B, C like this, and their corresponding values are 1, 2 and 9, but the column labels will be taken as the default values like 0, 1, 2, since I have not mentioned anything here. Now we'll go to the next program. Here I have converted a nested list to a data frame. You can see this is a list that will contain 3 rows and 3 columns, and these are the corresponding elements. Now let me run the program for you. While I'm running the program, you can able to see the output is 1, 2, 3. This is my first row. Then 4, 5, 6. This is my second row, and 7, 8, 9. This is my third row. Since I have not mentioned any row indexes or column index, that's why by default the row indexes are 0, 1, 2, and the column index are also 0, 1, and 2. Now suppose if I try to make change the row labels and column labels, so I need to write like this. Here the first argument is the data, so this whole portion is the data portion. If you remember the syntax, just let me open the syntax for you, it will be helpful. See, the first argument is data, that is the nested list. Now the second argument is index, that means row labels. Now how to mention the row labels? First we need to put a comma here, then we can write index equals to, within third bracket I need to put 3 different index. Suppose the indexes are A, comma, B, comma, C. Sorry, within single quote C. So these are the row index. Now let me run the program. Now see, the row labels are being changed. Previously it was the default row labels like 0, 1, 2. In this case it have changed to ABC. Now suppose let me try to change the column labels also. So how to do it? Just check the syntax. We need to mention the column attribute for that. So you can write like this, put a comma here, then write columns equals to, then again within third bracket you can write suppose x, comma, then y, comma, then z. Now let me run the program. You can see the column label is being changed. Initially it was 0, 1, 2, and now it has been changed to XYZ. This is the way to change the default row labels and the column labels. Now we'll move to the next row. Now you can see that I have converted a dictionary to a data frame. So let me run the program for you. See, in the dictionary I have 2 different keys. First key is A. This will be considered as the first column level, and second one is B. This will be considered as the second column level B. And all the corresponding values will become 1, 2, 3 along the columns, and 4, 5, 6 in the second column. This will become the value of each column. And I have mentioned the index. The indexes are X, Y, and Z. That's why the default indexes are being changed. It will become now X, Y, and Z. Now to the next one. Just let me copy this thing. Let me run the program. See, as I told you, there is a property that is we can change the types of the value along the columns, not along the rows. Just see, suppose I have created a data frame with the nested list. In the first list, and the first row I stored 1, 2.5 and L. In the second row I have stored blue, red and pink, three color name. These are basically string values. And in the third row I have stored three floating point type values. Now whenever I'm creating this, converted this to a data frame, it will become like this: 1 blue and then 75 7.5, and in the second column it will become 2.5, then red, then 8.9, and L, third one, then pink, and then 9.1. Now you can see along the rows, this is a row. Okay, along the rows all the types are like same, but along the columns we can change the type. First one is an integer 1, second one is a blue, that's a string, third one is 7.5, so a floating point. Now we'll go to the next one. No, see. Here I have converted a NumPy array to a data frame. Basically, I have created a NumPy array A by using arange function, arange 25. That means basically the elements that will organized from 0 to 24. Then I have changed its shape 5, 5. That means total 25 elements are present over there. Now I'm converting this NumPy array to a data frame by passing it as an argument in the data frame function. Then I have mentioned the indexes and the columns. That means I'm changing the row labels and the column labels. Now let me run this thing for you. Yes, the output. Just check the output carefully. So these are the elements from 0 to 24. The last element is 24. And since I have mentioned the indexes as A, B, C, D, so the row labels will become A, B, C, D, E. And for the columns, I have mentioned X, Y, Z. That's why the column labels will become X, Y, Z, W, P. So these are the basic ways to create a data frame from the other data structures. Now we'll come to the next point in our tutorial. Now some common attributes of data frame. What are the different attributes we can use? The first attribute is called, as you can see, index. By using index, we can only able to display the row labels. Next one is columns. The same thing, we can display the column labels. Then access. It returns a list. I'm putting more stress on this word list. And this list will contain two different values. The first value will be axis 0 index, and second value will be axis 1th index or the columns. Then the next attribute is size. We can display the size of the data frame. Then the next attribute is shape. All of you have a clear cut idea about shape. Like in my last tutorial also I have discussed about the shape. Next one is value. It will only return a NumPy array with all the values of a data frame. Next one is a empty. This attribute is used to check whether a data frame is empty or not. If it is empty, then it will give you true. Otherwise, it will give you false. Next attribute is endim. Endim means number of, and for number, and dim means dimension. So this attribute is used to return the total number of dimensions. Then the last attribute is T, capital T. It is used to return the transpose, index and columns. That means the matrix will be transposed. The rows will become column and the columns will become rows. Now let me demonstrate all these things with a program. Let me run the program for you. Now you can able to see the output. See, I have just used the last data frame that I created, the conversion of NumPy array to a data frame with the same labels, row labels and column labels also. So basically this is the output. Initially I have displayed the variable x. This is the output of x. Now in the next line I have displayed x dot index. As I told you, index means the row labels are going to be displayed. So check the output in the next line, the index A, B, C, D, E. So these are the row labels A, B, C, D, E. Next line I have displaced x dot columns. Column means this is going to display the column labels, nothing but x, y, z, p. See, x, y, z, w, p. Display. The next one is x dot axis. In the axis, as I told you, this is going to return you a tuple. Okay, within that tuple you have all the indexes and all the column indexes also. That means the row index and the column index. Next one is axis. Axis I already told you. Next one is size. Size will return you the total number of elements present in the data frame. This is 25. Now next attribute is x dot values. The value attribute, as I told you, this will return you a NumPy array. Basically this is a two-dimensional NumPy array because I am returning it from a data frame with all the values. The next attribute is x dot shape. The shape attribute will return you 5, 5 because 5 rows and 5 columns are there in the data frame. The next attribute is empty. X dot empty will return you false because this data frame is not empty or not null, I can say. It contains some elements. That's why the result is false. Next attribute is x dot endim. Endim will returns the total number of dimension. Since it's a two-dimensional, it have two different dimensions, axis 0 and axis 1. That's why you will get the output as 2. And the last attribute is x dot t. That means the transpose. Now check the initial one and the final one. See what is the difference. Initially 0, 1, 2, 3, 4 the element are present row wise, but in this final form you will get all this element column wise like 0, 1, 2, 3, 4. That means all the rows and columns are being interchanged with each other. This is the purpose of transpose. So I believe all of you have got a clear cut idea about this. Now we'll go to the next portion. The next topic that we are going to cover is indexing and slicing. Indexing means through the index number we can able to access the element, and sliced will return you a subset of the data frame. Now we'll check some programs on this topic. Just let me open the program for you. Okay, let me run the program for you. Now see, I've used the same thing. Up to this much the program is same. Now initially I have printed x, so this is the value of x. Then in the next line I have displayed x, then within the first third bracket I wrote x, and within the second third bracket I wrote a. That means initially the column label, x is the column label and a is the row label. So the element that is present with the corresponding x and a rows intersection will be displayed. So X column and A row, the corresponding element will be 0. So the first element that is going to display is 0. Now suppose if you want to change it, if you write it here like Z, that means the element that is present in the intersection of Z column and A row, the element is 2. So if you run the program, you'll get the output as 2. Like this, we can able to access a single element. Now, there is another way. If you write like this, X, then within third bracket, 2 colon 5. That means, so by default, this will take the row index numbers. Since we have used here a changed row label, then also computer will consider it as the default row labels. That means from second row to fifth row, you'll get the output. So row number 2, then 3, then 4. This 3 row you will get as output, excluding the row number 5. Now the third line. If you write like this, X, then third bracket, again third bracket, twice, then X comma Z, then twice the third bracket close. This will give you two different columns, the column X and column Z, with the default row labels. Check this one. This is the way to display multiple columns together. Now the next one. If you write this X, then twice third bracket, X comma Z, then twice third bracket close, then again 1 colon 5. That means you are going to display two different columns, X and Z. And you have also mentioned the row labels for them. The row labels are from 1 to 5. That means actually from 1 to 4. So B, C, D and E. These 4 rows and the 2 columns X and Z is going to be displayed. Now check the last statement. If you write like this is just an alternate way to display a single element apart from the second statement. So we can also write it like this, X dot Y, then within third bracket B. That means the element that is present in the intersection of label Y and label B. So let me check the element for you, label Y and label B. So this element 6. So you will get the output as 6. So I believe all of you have understand this thing. Now we'll go to the next topic. The next topic, I'm going to discuss some important functions of DataFrame. The first function is called head function. As you can see that the head function is used to return the horizontal subset. That means only the rows from the top of the data frame. Now the thing is that either you can pass any argument in the function as n, or you cannot pass. If you don't pass any argument, then only the first 5 rows will be displayed. And if you pass any number within that function, if you write here instead of n, if you write here 3, then only the first 3 rows is going to be displayed. If you write 2, then the first 2 rows will going to be displayed. This is the purpose of head function. Let me show you with the program. See, I have used the same data frame. Let me run the program for you. This is the output. Just check. Suppose in this one we have 5 rows and 5 columns actually. Now initially I have displayed the variable X, so I'll get the whole data frame as output. Now in the next line I have displayed x dot head, and I have not mentioned any arguments in this function. That means the first 5 rows is going to be displayed, as I told you. So the first 5 rows means A, B, C, D, E. All these rows are going to be displayed. Now, suppose if this data frame had more elements, suppose let me make it 36, and I'll distribute it in 6.6 order. And now let me run the program for you. Wait, I'm getting an error message for this from 0 to. Acha, I need to change the indexes also. I need to add one more index. Suppose after E, the next index is F, and here I need to add one more. After P, I can also add one more index as. Now it's okay. Now just check out. In the first case, the first statement X, you will get the whole data frame as output. All the elements that are from varying from 0 to 35. Then in the next one, head function is going to display the first 5 rows from A to E. The F1 will be excluded. That means head function by default displays the first 5 rows from the top. Now in the second line, I have mentioned an argument within the head function. So x dot head 3. So we'll get the output as first 3 rows A, B, and C. This is the purpose of head function. Now we'll come to the next point, is tail function. The purpose of tail function is to return the horizontal subset from the bottom of the data frame, which is the reverse of head function. So let me show you with an example. The same thing. Initially, the first statement print x will display the whole data frame. Then the next line x dot tell without any argument will get the last 5 rows. Since we have only 5 rows, so we'll get all the 5 rows here. And the third line x dot tell 3 will display the last 3 rows of the data frame. So only C, D, and E, last 3 rows will be displayed. So this is all about head and tail function. Now the next function is LOC. The purpose of LOC function is LOC get rows or columns with particular levels from the indexes. And another function is ILOC. ILOC get rows or columns at particular position in the index. So it only takes the integer. LOC function can take the indexes, and ILOC can take only integers as indexes. Now let me show you a program for this. This is the program. I have used the same data frame, and let me run the program for you. The first statement print x will display the whole data frame. Then the next line x.loc. The syntax is like this. We need to use a third bracket instead of a first bracket. So within the third bracket, we need to mention first columns, that means from A column, first the row levels. So from A row levels to D row level, all the rows is going to be displayed, then comma, then the column levels. From X column level to Z column levels, all the elements that are present within the intersection of this corresponding row labels and this corresponding column labels is going to be displayed. That means check from A to D, A, B, C and D, and the columns are X to Z. That means X, Y and Z. So that means the element that are going to be displayed 0, 1, 2, 5, 6, 7, 11, 12, sorry 10, 11, 12 and 15, 16, 17. This will be the output. Now the next one. If you write like this, x dot loc, then within single quote a, comma, then just put a colon. You have not mentioned anything. That means for the A labeled row, all possible columns is going to be displayed from start to end. This is like slicing. If you don't write anything before this column and after this column, that means from the starting column level to end column level, all the elements are going to be displayed. So check the output. See, these are the values for the first row. Now the next line. The same thing I have displayed. Here I have skipped the first index and I have mentioned the column level as Z. That means for the Z column, for all the rows values will be displayed. This is my Z column and all the rows values are corresponding row values are for A it will be 2, for B it will be 7, for C it will be 12, then 17 and for E it will be 22. This is going to be displayed. This is the purpose of LOC function. So I believe all of you have understand this. Now the next program, that is ILOC function. ILOC function is also like the previous one, just there is a little bit difference. See, if you write like this, x.iloc, the program is just like the previous one. The data frame is same data frame I have used. Just check the next line, this one. x.iloc, then I have mentioned 1:3. That means from the first to third row I'm going to display. That means first and second two rows are going to be displayed. Here I cannot write the row labels. To write the numbers or the default indexes. So this is the 0th row, this is the first row, B and C is the second row. So 1:3 means first and second, B and C, two rows are going to be displayed. Now for the columns, it is going to display 3:5. 3:5 means 0 is the X, then Y is 1, 2 is Z, then 3 is W and 4 is P. So 3:5 means 3 and 4 both the columns. So W and P. So all the element that belongs to the intersection of these two rows B and C and these two columns W and P, these are 8, 9 and 13, 14. These four elements is going to be displayed. Now one more thing that I'm going to discuss is how to convert a CSV file to a data frame. All of you are going to ask me that what is a CSV file. As I told you, data frame is nothing but a Excel like structure. Now let me create an Excel file for you. Suppose if you write like this, A, B, C, suppose, and then the corresponding values are 1, 2, 3, then 4, 5, 6. Now let me delete all the other sheets, sheet 2 and sheet 3. Now you need to save this file. So go to Save As. I'm selecting D drive. Then the file name is book1, and then the save type as, here you need to select CSV comma delimited, this option, and then click on save button. Then this dialog box will appear. You need to click on this button. The file will be saved. Now let me copy the program. See the output. I have made the same Excel file. This will contain 3 columns with a name, column label A, B, and C, and their corresponding values are 3, 4, 2, 5, and 1, 6. The same Excel sheet will be converted to a data frame. Now, how to do it? See the program. In the Pandas library, we have a function called read CSV. The purpose of this function is to convert a CSV file, not the Excel file. You need to remember this thing. The CSV file to a data frame. And within this function, as an argument, you need to give the full location of the file. Like I have saved that file in D drive. So just let me open my D drive. This is the D drive and this is the file. So how you'll get the full location of this file? Just double click on the address bar. Then you need to write here book. Then this full location will appear. Just copy this location and paste it as an argument to the function, and then the CSV file will be converted to a data frame. Now if you display the variable A, you will get the output. This is a way to convert a CSV file to a data frame. I believe all of you understand this thing. Now we have covered all the topics for today. The next day I am going to continue with the data frame. So thank you for today and prepare this thing.